right, so we're still on derivatives. This is called implicit differentiation, okay? Sounds real fancy. Going on page 43 when we're done. So I'm going to kind of read this to you. Up until this point, we've studied functions written in explicit form, okay? Everything we've done so far is in explicit form. We're going to look at these in implicit form. I will make sure you understand what all that means, okay? Meaning that one variable, y, is expressed as an output based on the input of the other variable, x. So everything we've done so far has been set equal to y or f of x or whatever that actually represented y, right? Y was all by itself. We might have a few terms with x, but there was just a single y there. So today we're going to explore finding the derivative in implicit form where they're mixed and we don't have, maybe we can't solve for one variable easily or we don't want to or whatever, that's going to give us our implicit where you can see that the x's and y's are mixed and we don't have just one thing solved for. Make sense? So I know we've seen equations like that. We've done, you know, I mean, like when you're doing systems, if you want to do substitution, you're going to solve for one and substitute in. If you don't, then you can do it other ways, but explicit, implicit. So just, that's the difference. It's okay if you don't necessarily know what they're called. All right, so we're going to go back and look at what it actually means to take a derivative. What we are doing, some of the notation that popped up yesterday that I know that y'all weren't super familiar with, and what our rules are and where this actual dy dx comes from and what it means. All right. So we have this equation, y equals 2x squared minus the sine of x plus 4, right? So if I want to take the derivative, I can put this around here and I'm going to say I'm going to take the derivative with respect to x. That's basically what that means right there, okay? So when we do this, what we end up writing is not y, and we don't really use y prime, we say the derivative, so dy dx, the derivative of y with respect to x, is equal to, and then we just take the derivative like we know how to do over here. Term by term, so I can use my power rule here. Going to give me 4x minus what? Cosine of x, right? Okay, everybody good with all that? That's what we've been doing. Okay, so by doing it like that, we are actually leaving off a whole bunch of notation because it would be really confusing at the beginning to show you all of that stuff. And I think if by showing you what it actually looks like if we put every little bit in there, not saying we're going to do every little bit on everything we do from now on, then our next step will just make a little bit more sense, okay? So remember that this means that I want to take the derivative with respect to x. So that what's really happening in the derivative here is when I take the derivative of y, it doesn't just magically turn into dy dx. What is the derivative of y? What's the derivative of x? Just x. So if I just have x, isn't that like x to the first? So it's just 1, right? The derivative of x is just 1. We know how to do that, right? So the derivative of t is just 1. The derivative of q is just 1. This is still the power rule, right? Even though they're different variables. So the derivative of y is actually just 1, yes? And so, but we're taking this right here is telling me to take the derivative with respect to x. Like x is what we're really kind of focusing on here. So when I take the derivative of y, that is 1. And then I multiply it. I have to put in a little notation that I just took the derivative of y with respect to x. Okay, does that make sense? Then that equals, so now when I take this derivative, just like I did over here, same thing, do my power rule, 4x, but then I need to say that what I just did was I took the derivative of x with respect to x. Okay, dx dx. Instead of dy dx, because it wasn't a y that I took the derivative of, it was an x I took the derivative of, right? And if the variables all fall off, I got to know if it came from an x or a y. You with me on that? Because this fell off, this tells me this was a y, not an x that I got a 1 from. So then minus, I take the sine of x, and look, this is technically the chain rule. So this, not the sine of x, good Lord. What is the derivative of sine? Cosine. So I take the derivative, I leave the inside alone, x, right? Then I take the derivative of the inside. Well, the derivative of the inside is 1, and then I say that was the derivative of x with respect to x. Okay? Even this is the chain rule right here. I did 2 times 2 is 4, right, to get my 4x. Then I take the derivative of the inside, which is x, which is basically just dx dx. And then plus, what's the derivative of 4? 0, and then dx dx. Okay. Now again, I'm not saying we have to add all that notation to everything, but that is actually what we are doing. Why do you think we just get to leave off the dx dx and it'd be okay? What's dx over dx? Isn't this just 1? Yeah. And isn't this just 1? And this right here is just 1. So then when we simplify it, like if we actually did all that stuff, then 1 times dy dx is dy dx equals, well, 4x times 1 is 4x minus cosine of x, because then it's just multiplied by 2 1s there, and then 0. And we end up with the same thing. So we were actually able to kind of take a shortcut when we first learned it. We left off all the dx dx stuff. So we're going to have to be writing more of the dy dx things. I could take the derivative here, and if instead of right here, if I put d over dx, I could have put d over dy. Then I can take the derivative of everything with respect to y, or t, or q, or whatever the variable is. Does that make sense to you? And whatever's in the denominator, since it's dx, anything with an x, I don't have to worry about putting that on there. Anything with a y, I do. Okay? All right, so stick with me. You understand how we kind of could have gotten all this stuff? And how it's really the chain rule, right? It's basically what's happening. Okay, so we're going to write this. And so it says, note, the derivative of y is still dy dx, because it's just 1 times that. Writing dy dx shows that we are taking the derivative of y with respect to x, like I just said. Okay? It still requires all of the rules. And like I just said, derivatives always require the chain rule. That's basically what's happening here. Okay? So let's look at this. If I want to take the derivative of x cubed with respect to x, since it's with respect to x, this is just going to be 3x squared. Because technically there's a dx dx there, but we don't have to write it because it's 1, right? I'm taking with respect to the x, and that's an x. I'm going to take this derivative with respect to y. I'm going to take this derivative with respect to x, but it is a y. So this is going to be 3y squared, and then I have to put on there dy dx, because the derivative of y is going to be dy dx, okay? If you have the same power rules, all the same rules we've already learned, all apply. But if you're doing anything with the y, you have to put a dy dx on it, okay, every time. Now let's look at this one. I got 2 terms. So when I do this, the derivative of x with respect to x is just 1, plus the derivative of 3y with respect to x. What's the derivative of 3y? 3. And then the derivative of y is dy dx. Okay. We okay with that? What rule am I going to need to use on d that I didn't have to use on the rest of them? I'm still going to have to use product rule, right? Because I've got x times y squared. Those are being multiplied. Got to use the product rule, right? So the derivative of the derivative of x with respect to x is what? 1 times the second, which is y squared. I don't put a dy dx on it because I didn't take the derivative. I just put the term in there, right? Plus the first, which is x, times the derivative of the second. What's the derivative of y squared? 2y. And then I have to multiply that by dy dx. Okay. What questions do you have? So the good news is no new rules, same rules, just if the variable happens to be y right now, we put a dy dx on it. We'll worry about other variables later after this makes a little bit more sense. Okay? Here's a list of guidelines. So we differentiate both sides of the equation, because these weren't equations, these were just expressions. With respect to x, we're going to collect all terms with dy dx on the left-hand side, factor it out, solve. Okay? So that'll make more sense once we do it. But they're the little guidelines. Guidelines are over there as well. So here we have an entire equation, right? And we're going to take the derivative. So I want to find dy dx. So I go term by term here. This first term here, all I need is the power rule, right? What's the derivative of x squared? 2x. And since that is an x, we don't need the dx on it, right? Plus, now we look at the second term. What rule do I use here? Product, because it's x times y, right? So I'm going to use the product rule. Make sure you don't only do part of the product rule, because the product rule is going to require two terms, right? So the product rule looks like this. The derivative of the first, which is just 1, times the second, which is y, plus the first, which is x, times the derivative of y, which is 1, and then what do I have to put? dy dx. dy dx. Okay? So I have 3 terms so far, but that's just taking care of these first 2. Yes? And then the derivative of negative y squared is what? Negative 2y. And then what do I have to put on it? dy dx. Then equals, what's the derivative of 3? 0. You want to know what a very common mistake is here? Is knowing what you're doing there and focusing on the dy dx, and that you don't forget product rule and you don't forget chain rule, and then putting equals 3 there and forgetting you're supposed to do anything with the 3. Okay? It's a very common mistake. So just make sure you still are, you're not finished taking the derivative. We're taking the derivative of both sides here. Okay. So now, that's step 1. We took the derivative of both sides. Step 2 is to collect all the terms dy dx on the left and all others on the right. Okay? So these two have dy dx in them. These two do not. So those two are the ones I'm going to move over to the right. Now, does it really matter if you go to the right or left? No, but that's what these rules say. So here, I don't have to have the ones in there. I just did that so we knew what was going on here. So this term right here that I'm going to leave on the left is really just x times dy dx. X times dy dx. Then this one's also left over here, minus 2y dy dx. Then equals, and also don't do something ridiculous by making up math here. I don't get to just plop them on the other side. I got to subtract them over because we know our algebra rules. This is going to be minus 2x minus y. Everybody good so far? Step 3, because on the left, every term that I have now has dy dx in it, I'm going to factor out the GCF, which is dy dx. Let me rephrase that. It's not necessarily always the GCF. Like if there was a 2 here, I wouldn't need to factor that out. I'm going to factor out the dy dx. That's what I should have said. So dy dx gets factored out. That leaves me with x minus 2y, and that equals negative 2x minus y. Everybody good so far? And we're trying to solve, is because it says find dy dx. Like we took the derivative, but we're trying to get dy dx by itself. So now that this is being multiplied here, I can divide both sides by this term, right? So this is going to give me dy dx equals negative 2x minus y over x minus 2y. And we found dy dx. Ask me a question. We okay with that? Now, if this was a multiple choice question, it's possible that what we just found, even though we're 100% right, won't match any of the answer choices. So here's a little something about these, just a little FYI so you don't have to do any crazy calculations or whatever. When you actually solve for dy dx and you have multiple terms in the numerator and denominator, if it doesn't match exactly, then you need to check the equivalent form, and all the equivalent form is change the sign on everything. So this is the same as 2x plus y over negative x plus 2y. And the reason that they're different, it makes a difference. Like had we moved all our dy dx terms on the right-hand side and left the other part and then divided over there like that, that's the answer we would have come up with. So which side you move it to depends on whether or not you get this or this, but they are literally the exact same thing. And you don't have to overthink trying to factor anything out or whatever. You just change the sign on everything. And if you got this, but this is one of the answer choices, that's your answer. Okay? Just a little side note on that. How are we doing? What? Okay, I know. It'll get better. It gets better. It's confusing because it's new and it looks weird, right? It'll be okay. It'll be okay. It's going to be fine. All right. I will tell you that apparently I have some trauma from learning this too, because last year when we were getting to this topic, I told Mr. Ackerman, I was like, okay, I'm going to go through and I'm going to rework all these things. I said, but I know that this, I remember, and it's been a long time, way before y'all were born, that I had this trauma. That when I first did this in calculus, like either I struggled with it or I didn't understand it. Like I don't even remember what it was, because after I started doing it, then I was like, he kept going, well, what was it they were getting? Was it this? I go, honestly, I don't know, because I don't feel that way anymore, but I still have that trauma that something was confusing to me at first, at least. So you'll get there, I promise. It's all going to be okay. Let's try another one, okay? So we're going to find dy dx. This is my equation, right? And so to do this, if it has an x on it, or it's only an x, nothing changes from what we've done before, right? So on the left-hand side here, what is the derivative of tangent? Secant squared. So secant squared of x is equal to, then term by term, so we don't do anything weird on these, I look at this 3x next. That's just the power rule, right? And so what's the derivative of 3x? 3. And it's an x, so I don't have to put anything special on it, right? What rule do I need to use in the next term? Product rule. Okay, technically they're all chain rule, but these are two functions being multiplied together, right? And it's minus that. We've got some options that include parentheses. I have chosen not to even show you that way because that turns into a hot mess sometimes. My suggestion to you is that negative sign is attached to that x. And just make sure you leave it attached to the x. That'll make your life easier on everything, okay? Pretend like that's plus a negative and the negative goes on the x. All right, so then I take the derivative of the first. So what's the derivative of negative x? Negative 1, right? So negative 1 times, so the derivative of the first times the second, so it's just times the sine of y. Technically the 1 itself doesn't have to be there, but just putting it there for sakes of making sure we know we did the derivative of something times something. And then plus the first, which is a negative x, times the derivative of the second. What's the derivative of sine? Cosine. And this is cosine of y, so what do we have to put on this term? dy dx. Okay. When you are done, however many y's you had in your original equation is how many dy dx's you should have in your final result there. Okay? So if we look back up here, I had 2 y's. Notice I ended up with dy dx in here twice. That's one way to make sure you didn't do extras or you didn't leave something off, okay? Now, am I finished? No, because we haven't solved for dy dx, but I got this far, okay? Now, the rules say to move all of the dy dx terms over to the left and everything else over to the right. Does it have to be in that order? No. Would it, in this one, maybe make a little bit more sense to leave your dy dx term? I mean, it's up to you, but if I look at this, I only have one, and it's on the right-hand side. So why move it to the left and other things to the right? Why not just move both of these things over to the left? You with me on that? Does that make sense? Still works right? And so if I do that, or would you rather stay consistent and move them to the left? Because I don't want to freak you out. It doesn't matter because you're used to solving equations, right? Okay, just making sure. So that means I'm going to leave my secant squared x. Then this 3 is going to move over, so that's minus 3. And then this is going to move over, so then that's going to be plus sine y. And then this whole term is going to stay, so that's equal to negative x times the cosine of y times dy dx. Okay. Any questions at this point? Yes, ma'am. Because this is all one term. Yes, because it's all stuck together. We're only moving what we can add and subtract first. Okay, that's a good question. Anything else? All right, so now I have just one term. So there's really, now our next step was really to factor out dy dx. There's nothing really to factor it out of because it's only stuck to one term, right? So instead, now I want to get dy dx by itself, so I'm going to divide by that part right there. So if I divide both sides by that, my left is secant squared x minus 3 plus the sine of y divided by negative x times the cosine of y. And what does that equal? Dy dx. Good. Okay. What questions do you have? Now, the equivalent form would be negative secant squared x plus 3 minus the sine of y over a positive x times the cosine of y. Could the three terms in the numerator also be in a different order? Yes, as long as the sign stayed with them, they totally, we could flip them around or whatever. Okay. And when I worked it out the first time, I actually did move everything to the left because I considered just following the directions and, making it like that for you, but I don't know that in practice really necessarily is important. And so when I actually got it, I didn't even have this form. This form of mine, these two terms are first and then this one just because of the order in which I moved them over. But they're all the same thing. And as long as you know they're all the same thing, you can find the right answer there. Okay? How are we doing? We good? Oh, so if we're just doing this because it tells us to find it and it's free response, fine. But if this is a multiple choice question and you were supposed to find it and this is your answer, there's a chance that that answer is not one of your answer choices, but this answer might be. And even this answer, the numerator, the terms might be mixed around, but the signs, it would be easy for you to tell it's the same, it's just in a different order. But they are equivalent, and instead of you trying to take this and making it into one of those forms and getting confused with the negatives and factoring out, just know that you change every sign. You don't have to write this every time. I just want it in your notes so that you know it's the same, and we just kind of talk about it as it comes up. Well, because again, why would they do? It's not to be a trick. It's because all it does is it depends on whether you move everything to the left or the right. That's what changes. It's not like, I'm not saying it'll never match. I'm just saying whatever decision you make when you're solving it, that's going to happen. And that's, as I've worked through multiple choice questions, sometimes when I get it, my answer's there, and sometimes when I get it, it's the opposite one. Okay, so no, it's not, you could do it to be tricky, but it's not. It just depends on, and when you're working with each other, if somebody decides to move everything to the left and somebody else to the right, then your answers could look different, but as long as you do this, then you're fine, okay? Because sometimes you might end up with one dy dx on each side and another term on each side, so really there isn't a, quote, best way. It's just whoever's doing it feels like doing that day. Okay, that's a good question. What else? All right. So here's the good news. If you have to actually use this equation, you don't have to solve for dy dx first. You can, but my suggestion to you is that you don't, that you stop at your first step, then substitute things in, then you're working with numbers and stuff and not all the crazy variables and whatnots, okay? So we're going to look at that here in example 4. So here's what this says. It says, write the equation of the line tangent to the graph. So I need the equation of the line tangent to the graph through this point. So if I'm writing an equation of a tangent line, the first thing I do is write down that I need a point and I need a slope. And the good news here, they gave me the entire point. I don't have to go figure anything out. They could have just given me the x value, but then there would have been some y's, so there's a reason they just gave me that. Now, the slope, what do I have to find the slope? the derivative. Good. And so we've been putting like f prime of 1 or something like that. Well, f prime here doesn't make any sense. So I need dy dx evaluated, that's what that little vertical line means, evaluated at the ordered pair 1, 1. That's what I'm going to need. Okay? So in order for me to be able to do that, I actually need the derivative, right? I need dy dx. But again, we're not going to have to go through all of this solving process. Yeah, we can, but I wouldn't suggest that we do. So I still have to do the same thing. So I'm going to take the derivative of this, right? Kind of do it over here so we have some room. So I take the derivative of this first term, and that's just 2x. And then the derivative of negative y cubed is going to be negative 3y squared. And what do I need on that? Dy dx. This is an equation, so I'll still need my equation. The derivative of 0 is 0. Okay? So even though this one, it's a little better to solve for dy dx, I don't have to. Okay? I can, but I'm going to need to evaluate dy dx at 1, 1. I can substitute in 1, 1 right here and get rid of the x and the y, and everything will just become a little bit easier. Right, so when I actually find this, right, I'm going to take, so this is going to be equal to, since that's equal to 0 right there. Oh, actually, let me not put equals just yet. We're going to substitute in the 1, 1, okay, because x is 1 and y is 1. That's where these are going to come from. I'm not making up stuff or taking another derivative. I'm going to do 2 times 1 minus 3 times 1 squared times dy dx. And that equals 0. Okay. Everybody understand what I did? I literally just used the ordered pair that they gave me. That's all I did. Okay. So 2 times 1 is 2. 3 times 1 squared is 3. Dy dx. I probably could have skipped that step, but I don't want to lose you because I know you're already not happy. And here now I'm going to solve for dy dx, which is going to be nicer to do without all the variables. I'm going to subtract my 2 over, so I get negative 3. Dy dx equals negative 2. Then what am I going to do? Divide by negative 3. So dy dx is going to equal what? 2/3. Okay. And so dy dx evaluated at 1, 1 is 2/3. So it's actually good when you need to evaluate it and you're having to do implicit differentiation. That's not really a bad thing because it's going to make everything a little bit nicer to work through. Now, are we done? We're not done because what did this ask me for? A line. Now, is getting that from all this information difficult? No, but you got to answer the question, right? So my equation of my line is going to be y equals my slope, which is 2/3, times x minus 1, and then what? Plus 1. There's the equation of my line. Okay? What do you think? Well, this is point slope. Slope, oh, you mean like y minus 1? Oh, yeah, that's totally fine. So basically this is that, just with the 1 moved over, but that is absolutely fine. I'm just trying to kind of move you into this one because there's kind of, and if you get here and then you realize you need it solved for y, you can just move the 1 over. Both of those totally fine. Really, any form you do is totally fine, yes. This is kind of like an amended point slope form. Yeah, so this is point slope form. Yeah, that's totally fine. Okay, how we doing? So here's another little bit of good news. When you were asked to take the derivative with implicit differentiation on the AP exam, you're usually going to have to do one on a free response question. So back in the day, they would give it to you, you'd have to do the implicit differentiation, then you'd have to use it to apply, and if you didn't get the derivative done right, everything else was a hot mess because you couldn't even figure it out. So what they have started doing is they start the question with something like this. They give you the curve, they give you the answer, you just have to show how to get there. That way if something messes up in there and it's a hot mess and you can't get that derivative to look like this, then you can still use this to do the rest of the question. You with me on that? That doesn't mean you don't need to know how to do it. Okay? And tell about, no, because of your reactions right now. That's why I'm saying that. No, I know, but today is our first day. We're going to get better at this. So we're going to at least start number 5, and we may restart it tomorrow. We need to restart it. But, yeah, we'll at least start it. We'll at least get the first step without actually solving for dy dx. How's that? All right, so when I look at this and I go term by term, okay, I'm going to use this term right here. What rule am I going to have to use? Product rule. Okay, so I make sure I complete the product rule before I move to the next term. So here I take the derivative of the first, so that's just 1, times the second, which is y squared, plus the first, which is x, times the derivative of y squared, which is 2y what? Dy dx. All right, so now I took the derivative of the first times the second plus the first times the derivative of the second. So I am done with that term. Like, double check yourself before you move on so you didn't just do half of it. Now, what am I going to have to do here? What kind of rule? Product rule. Where is that negative stuck? To the x. Okay, so I take the derivative of the first. What's the derivative of negative x cubed? Negative 3x squared. So that's the derivative of the first times the second plus the first, which has a negative on it, negative x cubed, times the derivative of the second. What's the derivative of y? 1 what? Dy dx. Very good. Equals what? 0. Very good. Okay, what questions we got? We good? You will be. You'll be fine. I'm not giving you an assignment today. We're going to come back. We're going to finish this tomorrow. Then we're going to work through some with deep breaths and positive thoughts, and you're going to be fine. Okay? We good? All right.